All right, welcome back from spring break. I hope you guys had a fabulous spring break. Today we're going to be covering chapter 10, just recapping on everything we did in chapter 10, and then talking a little bit about area and circumference of circles so that we're ready to go for chapter 11. You guys still have 2 assignments and a quiz this week, just like before. Your due dates have just shifted one day, so Wednesday night and Friday night are your 2 due dates. So just make sure that you're working through and completing this and asking if you have any questions. Again, today I'm going to recap. Know that this is going to be the first part of your assignment. So you need your 5 key points. Well, today I'm going to point out your 5 key points. Number 5 specifically will be the new content. So you need to make sure that you just have this note page written out. It's not a guided notes page. We just need to make sure that we understand the key pieces that we've covered in chapter 10. So notice today it says learning target is to recap all things circles. Okay, so again, I'm going to point out the 5 key points. You need to have these recorded as the first page of your homework. And then we're going to begin calculating area and circumference. So let's recap. The first thing we did in chapter 10 with circles is we talked about how to name them. So let's just recap on the parts of the circle that we named. And we're going to be using those parts as we calculate areas and circumferences and things. We need to make sure we're comfortable with those. So the first thing we talked about is naming a circle. You name it by its center. So if this is the point B, then we would name this circle Circle B, right? We use this circle symbol and we write Circle B. The next part of a circle that's very common that we will also use today is the radius. So again, a radius moves from the center to the outer circle. And again, if we write that as a segment, then that would be BA or AB. And we can either write segment AB or we can put this line over the top. Okay. Diameter also touches the center. It passes through the center and connects 2 opposite sides of the circle. So there's our diameter. Again, we need to be very familiar with diameter and notice that it's made up of just 2 radius pieces, right? All of these pieces would be the same length there, even though in my drawing it might not look like it. So if this is CD, then we can look at that diameter and call the diameter CD. Okay. The other ones were maybe the newer terms. A chord. A chord is any segment that has its endpoints on the circle. So this guy right here, and I'm just going to label that. This would be a chord. And so we would name it with its segments. It would be like chord EF, if that was E and that was F. Okay. We then had our secant line. The secant line just zoomed right through the circle, and it passed through and touched twice. So you can have points all over the place. We just would label this maybe M and this one P. And if I wanted to write the secant line, then that secant line would be written as PM with a line over it. Okay, or you can write the word line, M to P or P to M. The last one was a tangent, so we spent a little more time with this one. Remember, the tangent is the one that just touches the circle once. And we talked about, mine's a little crooked, but the tangent line, it touches at what we call a point of tangency. So this C value right there would be the point of tangency. That's where it touches the circle. And the line itself continues on, so we could label that as such. And then remember that the tangent line creates a right angle right there with that radius. So we did practice finding parts of the circle with our tangent lines, and we just remembered that the right angle is at the point of tangency. Okay. The other thing was the common tangent. So just remember, if we have a circle here and we have a circle here, okay, if those are touching, we talked about you can have external and internal. External mean they're touching on the outsides of the circles. Internal means it's not passing into the circles, but it's going between the circles. So if we're looking at external, that means it's sitting on top or it's below. This would be an external. This guy also doesn't ever pass between the circles, so he's also external. Okay. Internal then would be one that we're looking at that goes between the circles. So this one would just touch the circles there. Notice right there, it touches them. This guy right here would be an internal. So we just need to make sure we're comfortable with that vocabulary. Again, and neither of those can pass into the circle. So tangent means touches, never goes into the circle. Okay. Moving on to the second thing we talked about with circles. The second thing was the central angles and inscribed angles and the arcs. So just to recap again, central angles sit at the center. So if we have an angle here that say is 60 degrees, then it creates an arc, this guy right here, which is also 60 degrees. And we just talked about the terminology. If this is A and this is B and this is C, we would say that the measure of AC, and we'd put a little arc over it, is 60 degrees. Now notice the angle there is also 60 degrees, so we would say the measure of angle, that's the angle symbol, and then you start here and you move from A to B to C to create that angle. So we're saying from A to B to C, that guy was also 60 degrees, okay? And again, that is the central angle, sits at the center of the circle. Then we talked about inscribed angles. So we said, well, what if you take this central angle and you pull it all the way back to the circle? So we take this angle and again, we're gonna like pull it back, right? And we said that angle gets smaller, so it gets exactly half as small. So this guy right here, this is an inscribed angle, right? And it's half what that central angle would be. Notice they both subtend the same arc, so we called that the intercepted arc. Again, that's still 60 degrees. It's always the same as the central angle, but notice it's going to be twice as big as that inscribed angle pulled all the way back. And then we used those two properties as we looked at polygons that we put inside of a circle. So let's say we put a triangle in here, maybe. And let's say we're given that this here is 166 degrees and that this is 40 degrees and we want to find x. Okay, now we know that angles inside of a triangle are going to add to 180 degrees, but we need to find this one, this upper angle right here, so that we can use that property. And we can do that if we look at the arc that it creates. So here's our angle. Notice it's creating this arc out here. And remember, an inscribed angle, one pulled all the way back, is just half of the arc measure. So if that's 166, we take half of that, 166, right? Divide that by 2 and you get 83. So this guy must be 83 degrees. Again, now that's a triangle in there, so we know they have to add to 180 degrees. So we take 180 degrees and we just subtract out the 83 and the 40. And if we subtract that, it leaves us with 57 degrees. So we know that x must be 57 degrees. Okay, so those were those properties that we looked at. Always relating those inscribed angles. Again, the ones pulled all the way back, they're going to be half of that arc measure. The ones in the center are equal to that arc measure. Okay. All right. Let's look at our third point then. So we've got two of them down. This third one that we talked about, we didn't spend as much time on, but I do want to just make sure we touch really quick on it. So we talked about pie graphs. And when we look at pie graphs and how we represent them, we could either use our protractor and measure out some angle measures, or sometimes they're just thrown on, right, with data. And you can see here, if we had this and we wanted to know, okay, well, we created a 90-degree angle here. How much of the data in our pie graph would be represented in this 90-degree angle? Well, we just have to figure out the whole graph is 360 degrees. So we take 360 degrees and we divide that by 90. So if we take 360, oh, I just said that backwards. I'm so sorry. Take it back. We take 90 and divide it by 360 degrees, right? That's how we find percentages. And when you do that, you end up with 0.25, which tells us that 90 is 25% of that circle. Okay. And then we said we can also go the other way. So if we were told that we were looking at something with, let's say it had 18%. So now this one's in percent of the data was in here. And then all of these other ones could be whatever they wanted to be. If we wanted to figure out what this angle measure would be, so relating those percentages to degrees, then we could just say, okay, well, let's just go backwards. Instead of dividing, we're going to take 18%, so that's 0.18. Put a 0 there just to make sure we don't forget that's a decimal. And in this case, we just times it by 360. So if we take 0.18, we multiply it by 360, then we end up with 64.8 degrees. Okay. All right, the last thing that we covered in chapter 10.7 was the equations of circles and their graphs. Now this is really, 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 really important that you guys understand how to write the equation of the circle. If you understand how to build the basic equation, then no matter what information you have, you can use different techniques to find the two pieces that you need to find the equation of a circle and build that equation. This isn't one that can just be plugged in the calculator because it's not a function. So the y equals function that we generally use doesn't necessarily work unless you manipulate it around. So again, equation of a circle, if you didn't make it through that whole video, you need to go back and rehash that one. Equation of a circle looks like this, right? X minus h quantity squared plus y minus k quantity squared was equal to r squared. So just to rehash, we need two things when we create the equation of a circle. We need the center and we need to know the radius length. Okay, the center comes from this h and this k. So this is h and this is k. Remember, those are always opposite of what you see in the equation, and then there's the radius. Okay, so let's just rehash really quick. Again, if I had a center given to me that was 3, 1, and I had a radius of 2, then I could go ahead and graph this, and I could also build the equation. So to build my equation, again, here's my h, here's my k, and there's my radius. I would write x minus 3 because we do the opposite. That's my h value. Plus, I would do y minus 1 because of the k value equals r squared. Now if I take 2 and I square that, 2 squared is just 4. So there's the equation, right, of that circle. And then again, to graph those, we just need to make sure that we're getting the center in the right spot. So we would go over 3, up 1. Okay, there's the center of the circle. And if the radius is 2, then we just know that we're going to go 2 units in every direction. So 2 units up would be about right there. 2 units over, right there. 2 units down would be right there. And 2 units to the left. And then we do the very best we can to draw a circle. Oh man, it's close. Again, when I look at your guys' graphs, I'm looking that the center's in the right spot and that you have dots in all the right pieces there. And then I know it's kind of challenging to connect those. Do the best you can. Okay, that's kind of what we covered. Just really quickly with that, you're not always given the center and radius, so sometimes we need to find the other parts. So just remember, you need the center and the radius. Okay, and whatever you need to do to find that, great. We said sometimes you need the midpoint formula, so I'm just going to recap. The midpoint formula, right, was where we added the x's together and divided by 2, and then we added the y's together and divided by 2. we need to make sure that we know how to use the midpoint formula. So if you have the ends of a diameter, the center is halfway between, so you would use the midpoint. And then the other one we said, if you need to find the distance, or in other words, length. This is the same thing as length between 2 points. So maybe you need to find the length of the radius. Then you would go ahead and take your x values and subtract them and square it, and your y values and subtract them and square it. And you can find, again, this helps you to find the radius if you need to, and this helps you to find the center if you need to. Okay, so those are the first 4 pieces that you need in your notes recap today. I'm going to start a new video, and we're just going to talk about area and circumference of a circle. That will be number 5.